we go, Ian. Thank you.
Sounds good. Here we go. And please, anybody feel free to interrupt at any time as we move here. So I've just put together some lovely juicy photos of projects of ours and just some educational photos. This is a rig we recently completed here on a Stevens 47, a Stevens Hylas 47. And this is the first shakedown here on Port Townsend Bay. Fully synthetic rig, shroud stays, jib stay, forestay, high aspect rig, new Sparcraft mast. Some experimental details in there for us. This was still a little, well, there's so much backstory to fill everybody in on, but we've done a lot of engineering and working with synthetic fibers for well over a decade in this shop, but this one was still a bit of an experiment. And to be on this first sail and watch it all work was just an outstanding and exhilarating experience. And these guys are now somewhere far in the Western Pacific, and it's just proven that this stuff does work for ocean cruising. More pictures of the same boat, Stevens 47. I will just scroll through these here. Here we have jib stay, forestay doing their job. Once they got to Southern California, they left Port Townsend, headed down the coast, waited for their window to do the transpac, and got to Hawaii and complained of a little bit of chafe on these head stays. And that's one of the big concerns of this fiber, and one of only two of its vulnerabilities. And they sent some photos back, and I'm sorry I don't have those for this presentation, but it was really nothing to worry about. It was a little bit of surface fuzz around where the hanks had been riding. No strands had been worn through. Like I said, just some surface fuzz. And we're so accustomed to wanting to see no chafe on rope, or obviously no degradation in wire. And we really kind of have to retrain our mind in the way that we talk about and understand this material. Just because chafe is a vulnerability doesn't mean that some minimal chafe is a bad thing. And we can touch a little more on that as we go through these photos. Close-up details of a removable inner forestay. We've got Caligo ducks here with Caligo terminators married to a Wishard quick adjust turnbuckle. So just us enjoying the day. And it's hard to tell from this photo, but this upper shroud here is 16 millimeter. This was a discontinuous rig. So on all discontinuous rigs, that V1 is taking the load of a number of wires above it. And it was massive. And we had that on the floor of the shop, and it was felt like it was the size of my forearm. Like, this is going to look incredibly out of place on this boat, but in place, married with the rest of the rig, it just looks and feels so appropriate. This is the boat in front of our shop here in Point Hudson. This is Varia, a Phil Rhodes 27, actual 40. This was the 27 refers to the waterline. This is a rigger of ours, Jen and Peter Bates. This rig was put on Varia, gosh, 5 or 6 years ago. She gets raced pretty hard on the bay. The rig is holding up very well. We've mitigated some of the chafe that we found just from head sail sheet passing. And I think this next, just juicy pictures of us sailing. One of these next pictures will kind of highlight some of the chafe we saw. But you can see high aspect fractional rig. This boat has been in her family for years and decades, and her parents used to sail it. And once they put the Dyneema rig on it, they came down and they could feel the difference dramatically. She heels less. She's obviously staying more upright, less rolling, less pitching, flatter sails. So many benefits to this material. And a good example here to touch on an old wooden boat, the static tuning loads, like what that boat feels sitting at the dock, are significantly less than stainless wire would be. It has a lot to do with its overall strength, being 3 to 5 times stronger than the wire it replaced. So a very good material for old wooden boats. Here's a little bit of chafe I was talking about. This is just from a head sail sheet passing over the shrouds. This has since been mitigated and covered with leather. This was still nothing to be alarmed about. I think a lot of people might look at that and just be pretty freaked out about the amount of chafe. And if left unmitigated or just left to its own devices, yes, this would pose a problem over time. But I had no problem putting leather over the top of that, knowing that it exists. Like I said, 3 to 5 times stronger. That is such a minimal reduction in strength to not even be concerned about. some traditional details. We do a lot of classic traditional boats here in the shop. So here's some Caligo ducks married to a Port Townsend Foundry bronze thimble. This is an interesting picture here. You guys may be familiar with John Franta's Caligo Marine. And this is a rig that came to us just to recommission. We did not build this rig. The boat was sold. I think it came up from the Gulf Coast. So it had been in the Gulf Coast, it had been in the Caribbean, it had been in the Atlantic. And you can see the UV degradation on that thimble, how it's racked a bit in the jaw here. This thimble used to be black, and you can see evidenced here. And now it's very bleached out by the sun. So that's UV degradation. All this stainless was brand new when this rig was put up. And you can see the rust happening in the threads. You can see the rust happening on the head of the pin. Barely any degradation visible on this rope. It's just, we worry a lot about sunlight, UV, and chafe. But I can't say needlessly, those need to be paid attention to. But what we're learning is we can expect a equivalent lifespan to stainless steel wire with this material. Another detail, actually might even be the same one, but bleached out thimble, no visual degradation on that rope whatsoever. Consequently, if we go down, John Franta likes to put this heat shrink. It kind of keeps the splice compressed during shipment to the sailor. Underneath that rope has zero vulnerabilities working on it. It's protected from UV and it's protected from chafe. It doesn't fatigue in there because of load cycling. So it's, who knows the longevity of this material when it's protected from those two elements. Dare we say immortal. Consequently, or inversely, in the days of galvanized wire rigging, which we still do some of here in the shop, you had to protect it from the elements. So you would parcel and serve to keep the sun and the water off of it. We've uncovered properly served galvanized wire that was 80 years old and looked brand new once we uncovered it. I suspect in years down the road, we'll be experiencing something similar with Dyneema, heat-treated Dyneema. This is that same boat. The rig had been in service in the Gulf and Caribbean for 8 years. This is just minor surface fuzzing. There's no chafe here. This is just UV degradation of the individual fibers. And what we've learned over the years through testing this material is that initial fuzzing of the surface actually provides a bit of an umbrella, so to speak, to the fibers underneath it. So while the initial curve of UV degradation is tending upwards, after a season or two, this fuzz begins, that curve dramatically levels off because the fibers underneath are being protected by these the surface degradation. Here we are, a rig we're doing right now in the shop, a DIY customer for a custom unique Warham cat. He's serving at full length like we used to do with galvanized wire. And it's hard to imagine how long this rig will last. There is literally nothing acting against it. Chafe and UV are completely erased once it's served. And as long as he maintains any chafe through that same twine service, this rig ain't going anywhere. Just another example of a full-length service on synthetic rope. This, again, it's a lot to cram into this talk, but kind of gets into some of the survey details. I would say it's going to be extremely rare, if not the case in every scenario, that spreader tips are going to need to be mitigated for this material. A well-designed spreader tip for wire is not going to be appropriate for rope. It's either going to pinch the wire, it's going to be too small for the rope, there are going to be sharp points, it's going to be cast aluminum, which may have a rough surface. So this is one we literally cut the spreader tips off and had a local manufacturer here, Ed Luchard of Zephyrworks, very well-known shiv maker. And he's done this for us a number of times now, build custom Delrin shivs, custom Delrin spreader tips, excuse me. And I think somewhere else in this photograph, you'll see a different close-up of this. One needs to be careful of the radius and one needs to be careful of chafe. Radius would be the bending radius, which we can chat about a little more a little later. Spreader tip detail. Going back to that Stevens 47, this is a spare rig for that boat. When we first got that contract, the lead shipwright came up to me and he said, "Oh, by the way, the owner wants a spare rig." And I said, "No, you mean a spare shroud?" He said, "No, we want a spare rig. You build one jib stay, you build two jib stays." So subsequently, we built two of everything for this rig, folded this one up, bundled it up, put it in a duffel bag, and it lives somewhere on the boat. And I explained to them, it's going to be very unlikely that they will need to even open that duffel bag anytime in the next decade. They said they know, but we've got it if they want it. It's all built to length. It's been stretched. The thimbles are in there. It's ready to go. The other interesting part about this is this complete rig for a 47-foot boat weighs 48 pounds. The original rig weighed about 150 pounds. 150 to 180 is my guess. Excuse me. What we've learned through the employment of this stuff is you can expect about a 75% weight savings. And I don't think I need to explain to anybody here what that means for a sailboat. That's dramatic. You've reduced your heeling moment significantly. Not only is that more comfortable sailing, it's safer sailing. It's potentially, from the design phase, a lighter weight keel, or a better performing keel on a boat that's already built. Just that idea that 1 pound of weight 30 feet aloft adds 30 pounds to the riding moment. We've reduced that significantly, as well as upping the strength of the material. It's a little mind-boggling. Again, Stevens 47 looks like a V1 there in the close-up. Stevens 47 rig on the floor. Hard to tell from the perspective that that large turnbuckle is 7/8. That runs about up to my kneecap. This is an interesting one here. A big question of this stuff is the vulnerabilities. People focus on the vulnerabilities. And again, we have to kind of change the language with which we talk about this material as opposed to wire. Yes, UV light will degrade this material. And this is a chart showing UV degradation over the course of the years. If you look on the bottom, we've got 2 years, 4 years, 6 years, up to 10 years. I'm going to focus where that line ends. And it says that material at that point has been reduced by 60%. It's now at 40% of its breaking strength. Our understanding of standing rigging would be, this is absolutely unacceptable. That doesn't work. If that was stainless steel wire, it likely would have been close to failure, if not failed at that point. But what we have to understand is we're starting out with a rig that's 3 to 5 times stronger than the wire it's replacing in the beginning. So that 40% of its break strength is not a concern. I'm just going to have to look at my chart here. If you think of 11 millimeter Dyneema, which is a pretty common size for your average 40-foot cruising boat, the equivalent would be 3/8. 3/8 stainless steel has a break strength of 14,800 pounds. 11 millimeter Dyneema has a break strength of 36,000 pounds. A 40% reduction in 36,000 pounds is 14,400 pounds. You're now, after 10 years, you're now at the break strength of the wire that it replaced. And so that break strength is not what we designed to. We've got a safety factor. So the working load on that 3/8 is going to be, 2.5 to 3 times less than that max. In actuality, it's only going to be a few thousand pounds. So the UV argument, as long as it's mitigated, is not really anything to condemn this material. And I think what we're learning, it's been out there for about 10 years in the tropics, crossing oceans. We very well may start seeing synthetic fiber SK75 heat-treated Dyneema last longer than stainless steel rigs. Right now, I have all the confidence to say an equivalent lifespan. Excuse me, if you will. My nose has decided to act up a little this morning. Chafe is the other issue that has to be mitigated. Chafe will be a killer to this material. And the common argument with people is, what happens if I bump into it with my knife? And my common response is, what are you doing walking around with an open bladed knife next to your shroud? It's about as common as me walking down your boat with a hacksaw in my arm, just bumping into your 1x19 wire. It's very unlikely to happen. But we put it to the test. We have a stretch bench in the back room to post-stretch this material. We stretched a piece of, I think it was 9 millimeter, up to the load it would be tuned at on a boat, sharpened the knife, got out the ceramic knife, which is really efficient at cutting this material, and put on our protective gear because we figured this thing was going to explode on first tap. I tapped the material and it sounded like metal on metal, just ting, no fibers displaced, tapped harder, nothing. Any sort of banging on the rope with the knife did not result in any fibers parting. I literally had to apply force and a sawing action. and it probably took 10 minutes to cut through the material. And as this material fails, there's no stretch in this material, unlike nylon or even wire, which when it parts, it recoils. You hear the tragic stories of tugboat operators being beheaded when a cable parts. There's just so much energy stored in there. This doesn't store that energy when it parts. It just compresses on itself and falls to the deck. So again, mitigated chafe from sheets, spreader tips, maybe sails passing back and forth is important. But yeah, don't worry about your knife. Just threw this one in here. One of my favorite tools in the shop is a little 100 to 1,000 power pocket Wi-Fi microscope. I take this on every survey I go to, and we open up, look at the wire, and this detail right here, this is a piece of failed 1x19. And to the naked eye, the wire was discolored and a bit rusty, and I could nearly tell that it was too old, needed to be retired. But this failure was, you could not see with the naked eye. You had to get out the microscope. And it just highlights stainless has so many vulnerabilities, and it doesn't announce them. Crevice corrosion, pitting, work hardening, fatigue, so many other metallurgy, and then problems with terminations. What's happening inside of your swage terminal where it's anaerobic and wet. So much of this stuff you don't know until it's exploded. Non-destructive testing, all these things. Dyneema fiber standing rigging is fully inspectable, every square inch of it with a naked eye. No specialized tools, not even a bunch of specialized knowledge, just kind of basic understanding of the material. And it's through this that the US Coast Guard has declared it the safest standing rigging available, which I think is a remarkable statement. There are a few other synthetics out there, Kevlar, carbon, PBO. Carbon is fantastic material. It's very expensive and hasn't really reached the average cruiser's budget at this point. But carbon and PBO have incredible vulnerabilities. They have no tolerance to ultraviolet light. And I think it's PBO has no tolerance to being wet. So I don't know why you would put something that doesn't like sunlight and water on your sailboat. Again, just other close-ups of stainless 1x19. I like to say that stainless ages like human skin. Our pores get deeper and they start to stretch out. And if you look at this, that's exactly what you're seeing on this wire. This is just a pile of rig. This is for the Warham Cat, the 40-footer. That's the entire rig right there. Again, it weighs less than the Stevens 47. That's probably a 35-pound complete rig for a high aspect mast on a more traditional style catamaran. Close-up terminations here, close-up of terminations. Again, this is Varia, the Rhodes 27. There's an idea of bend radius. We can't just take this stuff and bend it around the clevis pin here. Can you all see my cursor as I'm moving around? If we were just to take this material and bend it around that pin, yes, it would probably be strong. Yes, it would probably last for a little while, but you've put the inner strands going around that radius in compression, the outer strands under excessive tension. They're imbalanced, which means fewer fibers in the rope are taking the overall load, which results in a significant reduction in strength. The base bending radius, kind of the bare minimum we would say is a 5-to-1. So 5 times the still will have about a 20. We'd prefer an 8-to-1. It's a little big, but at around 8-to-1, you're still maintaining about 100% strength of the rope. In that, for the surveyors, I had to back up a little bit on this one. There's the YouTube phenomenon of sailors right now. You'll see a lot of people teaching you, quote unquote, how to build synthetic standing fiber rigging. I've waded through most of them that I could find, and there are very few that are portraying accurate information. John Franta from Caligo Marine, he's got stuff up on YouTube on how to use this stuff and how to employ it. Trust everything that he says. Some of the others, and I don't need to go into them by name, some of them are portraying dangerous information. Some of them are making it work, might be a little inefficient, but I give it to them, making it work on a budget. But be skeptical if you're surveying and you see this material employed with off-the-shelf hardware that's made for wire rigging. The properties and the needs are different. Sometimes I'll even see people tuck in these terminations at the end with thimbles that are made for running rigging, thimbles that are made for halyards, and they're putting standing rigging loads on them. So between things like that and between people using the wrong type of Dyneema, people just going and getting Samson's AM steel because it's Dyneema and employing it as standing rigging and getting significantly too much stretch, the stuff has a little bit of a bad name, and there are a lot of skeptics out there. When you use the right material, heat treated SK75, you're going to have a piece of rope standing rigging that's going to behave better than stainless 1x19. Better in that it's lighter, less vulnerabilities, easy to inspect, and it's going to have the same stretch characteristics that you target for elongation and stretch rather than strength with this material. That's just a little promo for our shop I'm going to throw in right there. Long story about this shop and our history and my coming in, but we'll have to save that for another time. And that's the show. I can keep talking technical data, or we can just open this up for a conversation.
Thanks, Ian. Who wants to fire some questions towards Ian?
Quick question, Ian.
Yeah, go right ahead.
I know you sort of, with all the rigging, I don't know how many boats it's on at the moment and how much it's being serviced. And I said, you said there's a lot of Caribbean, a lot of stuff down the Caribbean. Where, if anything, are you seeing with any failures, any sort of regular failure points?
Regular failure points. I'm not privy to, I'm trying to think of one failure that I'm aware of, and that's not me just trying to promote the material. I mean, I have an example on the desk here. I don't know how clear this is going to show up. This is a soft shackle that we have in the shop that we load tested to destruction. And this is where it broke. It broke in the eye. I don't know if you're all familiar with the soft shackle, but one end is going to have an eye. This one broke there. And it's all about that thing I was just mentioning about bend radius. This eye was bent around a radius that was only 2 times the diameter of the rope. And it still broke at, gosh, what did it break at? 25,000 pounds, which this is 11 millimeters. So what did I say that was? 36,000 pound strength. Bend radius and chafe. Spreader tips are going to be a vulnerability. We've commissioned a boat, and I thought it was in that slideshow. It was a Kaufman 47, same boat that John Kretschmer sails. Lovely boat, full synthetic rig. Oh, it was the one with the UV degraded Caligo thimbles in there. And they used the original spreader tips made for wire. And then they put a lovely leather spreader boot over the end of it, so you could not see what was going on in there. And we opened it up just because I know it's a vulnerability. And it was chafed, but it wasn't chafed enough for me to condemn the rig. It was just kind of surface chafe. They had treated it with some Dyneema string, served it in that section. But that's going to be the weak point on that rig at some point in time.
And also, with sort of being down the Caribbean, knowing the area pretty well, I spent a hell of a lot of time down there. Are you seeing any sort of growth? Are you getting any biological growth in between the fibers in and around with the sticky, horrible weather down there sometimes? The best of it.
That's a super interesting question. And I've actually heard nothing about that in any of the data, in any of the books or any stories. And it brings up a very valid point. I'm just going to make myself a note to look into it. Well, it's interesting. I don't know that there would be any growth that would degrade the material measurably.
Yeah.
But it's still worth looking into it. You see it all over on stainless, mostly up here where it's wet and dank.
Yeah, and especially down in the Caribbean, I had the fortunate timing or unfortunate timing to be on Salperton when her rig came down. And we were hacking away the PBO rigging with bread knives and stuff like that to let the rig sink to the bottom of the ocean just off Antigua there. And
how much time did that take to free the rig from the boat?
About half an hour.
Yeah, God, wow.
But yeah, with that, I just sort of hearing all the whispers on the grapevine with the guys from the boat and stuff like that, and still a lot of people are pointing fingers at growth in the PBO rigging that caused the failure.
What boat was this?
Salperton.
I'd love to read some more about that. I don't know if anything's published or who's doing the chatter, but yeah.
North, Southern Spar's rigging is pointing the fingers at North Sails, and North Sails are pointing the fingers at Southern Spars. So yeah.
It's a tricky thing, we joke about that stuff, and I like to tell people jokingly that our warranty ends as soon as your boat is wet. You can have a very well-built boat, a very well-designed, properly designed rig. Everything can be perfect, pass every inspection from us or the Coast Guard, and the owner can get out there and do something funny and the rig comes down. It has nothing to do with us, but who's the insurance company going to look at?
Yeah.
So yeah, the growth is interesting. I'm sorry, yeah, I don't have any data on the growth.
No,
Yeah.
right on, cool.
Yeah. Plenty more to talk about on this stuff. Again, we could go down rabbit holes for days. I love questions, and to make these things more of a conversation. If anybody wants to jump in with anything, or I can start rambling.
Sarah.
Off.
You're
that, Sarah?
muted, Sarah.
Jesus.
We're all still figuring stuff out.
What are the cost differences between your standard steel rigging and then going synthetic Dyneema?
Yeah, great question. With a number of, I can make an answer, but there are a number of asterisks after that. It depends how you approach it. If someone hires us to do it, the rig is going to be more expensive than a stainless steel rig. Those costs are coming down as our process becomes more efficient. Our process and our equipment becomes more efficient. The way to make this stuff affordable is to learn how to use it and do it yourself. The splice is the easiest braided rope splice there is. That's really a no-brainer. The technicalities come in dimensioning the material properly, getting the right diameter, and calculating and understanding how to make a fixed length that's not gonna creep, that's gonna be appropriate for the boat. Having said that, the per foot price compared to stainless 1x19 can be 2 to 3 to 4 times as much as stainless 1x19. When we first started doing these rigs, they were coming in at about 3 times as much as an equivalent stainless rig. And so it took people who just really loved the experiment and had deep pockets, and money wasn't so much of an issue. As we've become more efficient, we got it down to 2 times. And on some of them, we're even a little less than 2 times as expensive. It just depends on how we outfit the boat. Yeah, but like I said, our process is getting quicker and quicker with each rig. And the early days, we're taking notes, we're trying to understand the creep and the stretch and the splice take up in the material, and how do we elongate it after you splice it. So yeah, there are a lot of those YouTube phenomenons saying that it's the most affordable rig you could own, and for those on a budget, it can be, but you're going to have to do the work yourself to make it happen.
So as marine surveyors, what we've got to be doing is talking to our clients and finding out where their rigging has been made, who has completed the rigging, in order for it to start to raise alarm bells for us.
Yeah, I think that would be an important question to ask, for sure. I think there are a number of important questions to ask as a surveyor. It's also going to be you understanding, is the material dimensioned properly? Is it the right diameter for the boat? Well, even if it's 2 or 3 sizes too small, it's still going to be strong enough. That's not going to be so much of an issue because the stuff is massively strong. But it's going to stretch too much, or excuse me, it's going to creep too much. And creep is that slow elongation over time. Like the target creep that we go for is 1/8 of an inch per year with this stuff loaded up dynamically and static tune cyclical loads at the dock. So 1/8 of an inch a year, that's 1 inch in a decade. That's totally manageable by a short throw turnbuckle, a turnbuckle that might have 6 inches of adjustability. You're gonna see, so if you get on a boat with a synthetic rig and you see 2 blocked turnbuckles that are more closed, you might want to analyze the diameter of the material, do the load calcs for the boat, determine what size 1x19 it should have, and then do the equivalent stretch in Dyneema fiber. Bend radius is another one to look for as an inspector. What I was saying, what is the Dyneema terminated with? What type of thimbles or terminations? And what is the diameter of them? Like we said, minimum 5, ideally 8. 5 is going to be a 20% reduction in strength, give or take. 8 to 1 is going to be close to 100%. I would want to, I think everybody surveying a rig has to climb. If you don't go to the masthead, you did not complete a rig survey. You just had a casual look around. And especially with this stuff, like I said, the spreader tips are going to be a big vulnerability. It's a stress riser where the rope is bending over a material, even the wires, where it bends and turns a corner, where any load has to turn a corner as a stress riser. And there's a chafe potential in there. Again, this goes to more boat owners, and I think you as surveyors can understand this. How lovely is it to step on a boat for a survey and find documentation of everything that's been done to the boat, from receipts and notes and notebooks. So if they have receipts of the material, you're going to know who made the material. Is it the heat treated SK75, or is it just West Marine's off the shelf Amsteel? It might say the rigger that built it, or give you some education as to the scantlings of the material. Geez, so many other things, like the pictures I showed of the Dyneema that had the surface fuzz happening, that was just from ultraviolet degradation and then subsequently went to protect the fibers below it. I wish I could say what degree was tolerable, what degree of chafe was tolerable, or UV degradation was tolerable. We don't really know that at this point yet. But all the pictures I showed of that chafe, that was tolerable and acceptable. And anything beyond should be questioned. That's going to be a little bit of a gray area as to how much of that you can tolerate. I wish I could elaborate something more scientific on that, but yeah, it's going to be a little more intuitive.
We've got a couple of hands raised, Ian. The Beatles, and then Bob.
Yeah, a few years ago, I had a claim on a 52-foot sailboat with stainless steel standing rigging that got underneath some DC hydro power cables, and 340,000 volts went down the rig. And I wondered if you had any knowledge about how this material that we're discussing would behave in, say, a lightning strike. I can't say firsthand experience with a lightning strike, but I have experience with I have experience of a story of a high voltage power line introducing 115,000 volts into Dyneema. Yes. Again, no names need to be named, but there was a boat that we rigged. It was an Ingrid, and this happened out of town. It was going for some work on the yard, I think some bottom job or something. It was hauled out, and while it was traveling through the yard on a travel lift, it impacted the city's high voltage power. The jib stay impacted the city's high voltage power line. Nobody died. The boat was not damaged. The jib stay was fine. Went up and inspected every inch of it. There was no burn mark. There was no nothing. This material, as I'm sitting here shredding it as we're talking, HPME, high modulus polyethylene, is basically UHMW. It is the material that forms the insulation of electrical wires. It is absolutely non-conductive. Had that boat that impacted the power line had a stainless stay, you know very well what would have happened. It would have not only damaged, it would have destroyed likely the boat. It would have blew out the tires on the travel lift, grounded the travel lift, killed the driver, killed his ground crew, and possibly introduced severe burns on the legs in a vicinity. So, you know, how much a lightning strike is going to be different, I can't really speak to, but the material is non-conductive. Alternatively, your mast and other metal hardware on your boat is conductive. Again, I haven't heard any boats that have encountered a lightning strike with this material, but it's non-conductive. Yeah. Okay.
Hey, Matt, this is Bob Peaver here. I'm a little curious about the how you measure the tension when you're installing or tuning Dyneema rig.
Another good question. The smaller diameters, maybe like 6 through 9 millimeter, we have calibrations for a loose tuning gauge. We can just clamp the loose tuning gauge on the Dyneema and calibrate and extrapolate the tension and go from there. The larger diameters, we don't have that.
There are other, gauges that will work, but the way we do it with the larger diameters, so anything above 9 millimeter, which, 10 is really unavailable, so 11 millimeter and up, we just do a dockside tensioning or a dockside tune to get it relatively taut, get a little bit of a tone out of the material, keep the mast centered and in column, introduce a little bit of bend or rake if it's necessary, and then go sailing. The biggest telltale on this stuff is you want that rig, your mast, to stay straight and in column, right up to the point where you're going to tuck a reef. You want to see a little bit of masthead fall off right at the point where you need to reef. So then we'll reef, we'll sail it some more, and I want to see that mast stay straight and in column up to the point where we're going to tuck a second reef, and so on. So that's really the idea. I think over time it'll become a bit more intuitive. We might develop some different tools, but also with this, it gets back into the fabrication of the material. When you introduce a splice into the rope, you've disturbed the braid. So you then need to reset it via tension. So you tuck that splice, and then we tension the rope to degrees of magnitude beyond what it's going to experience while it's tuned on the boat. That's going to reset that splice, take all the hollow airspace out of there, reorient the fibers. And like on an 11 millimeter piece of wire, I think that's going to be 3,000 or 3,500 pounds. We just do that once, and it only has to be there for a couple seconds, and it's set. We go put it on the boat. But when you're out there sailing, that first sail or two, you still might have a little bit of elongation in that splice. So that dynamic tune is also very important.
Gotcha. Interesting. Thank you, Matt.
Yep. And just to follow up again, like I said earlier, your static tuning loads, what the boat feels at the dock, are going to be dramatically less than if it was stainless wire.
Mhm.
Less stretch, higher strength in this material.
Right. Great. Thank you, Matt.
Pleasure.
Any other questions?
There's Brian, the namesake of our shop here, wrote an article for Wooden Boat Magazine, 4 years ago or something. And I should probably not even talk about it because I don't know the issue and I don't know the title. But if you guys want to email or something, it's a fascinating multi-page article on the benefits of this material and its benefits to older wooden boats, lower tuning loads and such. We recently wrote one in Professional Boat Builder on more of the mechanics of fabrication of the material. You can find, 5 or 6 months ago it was released, I believe.
Wonderful.
Yeah.
Thanks, Ian. Tremendous. I mean, it's such an interesting topic, and it's one that we've covered off 2 or 3 times. We published some stuff on it. And
You guys have published something fantastic, and I've got a copy of it here on the deck, the book by Nicholas Parkin.
yes, yeah, good old Nick. Yeah.
It's a fantastic resource, and I encourage anybody who thinks they might be surveying these boats to read that. Nobody can improve on that data right now. He, like all of us, is resting on the shoulders of the giants who have done the work before. But this is it's not ever far from the desk.
Yeah. No, fabulous to see you've got a copy. It's available on the IMS website. I don't know, it's $50 or something.
Yeah.
It sells very well, and it's coming technology. It's here now, but it's very much coming technology. Ian, great to meet you. Thank you very much.
Likewise.
Indeed.